Okay, so we're going to continue on talking about graphing quadratic functions in standard form, and these can be in standard form. And so remember, standard form looks like this: f of x equal ax squared plus bx plus c. That's standard form. So not vertex form, that's standard form. All right, so remember, this is a continuation of a previous lesson. So let's look at number 3. So number 3, I have this quadratic function. So let me go ahead and rewrite it. So this number 3, it's g of x equal 2x squared minus 2x minus 5. All right? And so I want to find, and so in graphing a quadratic function, you must always find the vertex. So let's find the vertex. So remember, the formula for finding the vertex is hk, hk, where h is the opposite of b divided by 2a. All right, now remember what a, b, and c are. So a, remember, is a coefficient of x squared, so a is 2 here. B is a coefficient of x, so that's what this is, so that's negative 2. Make sure, it's very important, you are careful with your signs. And c is your constant, so that's negative 5. All right, so if I want to find the x-coordinate of the vertex, so that'll be negative b over 2a. So I'm going to have, if b is negative 2, the opposite of negative 2 is a positive 2, divided by 2 times a is 2. So I get 2 divided by 4, which is a half. Okay? All right, so that's the x-coordinate of the vertex. So far, my vertex is 1/2. Now we got to find the y-coordinate. All right, to find the y-coordinate, which is k in this case, remember, so to find that, you're going to find g of 1/2. G of 1/2. Okay, now here's what you would do. So where we see the variable x, you're going to substitute what we found for h, which is 1/2. So you're going to get 2 times a half squared minus 2 times a half, and then minus 5. All right, use your calculator with this. I mean, I know it has a fraction. Don't let the fractions throw you off. Use your calculator. So this is what you have. You have 2 times 1 divided by 2, close the parentheses, that's being squared. So I'm just going to square this, just like this. Oops, sorry. Let me go back. So let me delete. All right, so I pressed the wrong one. So I'm just going to square this right here. All right, and then minus 2 times 1 divided by 2. Close the parentheses, and then minus 5. All right, now if you do this correctly, make sure you got something that looks like this. Okay. All right, so negative 5.5. So there's my y-coordinate, negative 5.5. And I know negative 5.5 terminates, and I know that negative 5.5 is negative 5.5. So if you want to write negative 5.5, you can. So there's your vertex. So 1/2, comma, negative 5.5, and that's it. That's your vertex. So just because you had fractions, it's just not the end of you completing this problem. All right, now let's talk about this vertex now. So I know that the vertex, so vertex is 1/2, negative 5.5. So I know that the vertex is in quadrant 4. Now my next question is this: does the parabola open up or down? So remember, you look at A. If A is positive, the parabola opens up. So it's going to do something like this. Okay. So I know now that I'm going to have some x-intercepts. So we're going to find those at some point. All right. If it went down, then there would be no x-intercepts, but you would still need to find 5 points. Need to plot 5 points. And there's in one of the problems in the previous lesson, you saw how to do that. All right, but at least we know we have x-intercepts here. Okay. All right. So far we have this. So far I'm going to fill in the blanks. I know the vertex. So the vertex is 1/2, comma, negative 5.5. Oops, sorry. Negative 5.5. And make sure you put it as a point, so it's got to be in parentheses. So when we denote points, you need parentheses. Now remember, this is a quadratic function. This is a quadratic function. It's a polynomial function. So the domains are real numbers. So negative infinity to infinity. All right, now the range depends on where the vertex is and whether it's a max or a min. So notice that this vertex here is a min. So to find the range, remember the range is a set of y coordinates. So since it's opening up, this is the smallest point. So that means that this y coordinate, and so remember this is 1/2, negative 5.5. So my smallest y coordinate is negative 5.5. So it'll be negative 5.5 all the way to infinity. So bracket negative 5.5, comma, infinity. So there's your range. All right, let's talk about the y-intercept. So remember, this is in what form? Is this in vertex form or is this in standard form? Well, if you said standard form, you're correct. And so remember, to find the y-intercept, you're going to let x equal 0. But the point being, and again, we've talked about this before, the point being that if x is 0, that means that this term is 0 because 0 squared 0. This term 0 because 2 times 0, negative 2 times 0 is 0, and you're left with your constant. So the y-intercept is always your constant if it's in standard form. All right, so I'm going to have 0, negative 5. There's your y-intercept. So I have that. Okay, now let's go and start graphing what we know so far. Okay? All right, so I think I can go ahead and use a smaller graph. So let me get a smaller graph here, and we're going to plot those points. All right, so here's what I have. All right, so my vertex is 1/2, negative 5.5. Now I'm going to go ahead and expand this so you'll see it a little bit better. All right, so my vertex is 1/2, okay, negative 5.5. So negative 5.5, well, 1/2 negative 5.5 is about here. See what I did? Right here. Okay. I know my y-intercept. My y-intercept is 0, negative 5. So I'm going to plot that. So that's right here. Now remember, the next thing you want to do is draw your axis of symmetry. Draw your axis of symmetry. That's the next thing you want to do. So I'm trying to find my ruler. So when I draw the axis of symmetry, I am going to get, so when I draw the axis of symmetry, I'm going to get, and let me go ahead and use a blue line here. Remember, the axis of symmetry goes through the vertex, so notice what I'm doing. I'm drawing it going through the vertex. Now listen, just like we talked before, if you know the y-intercept, and remember, you're always going to have a y-intercept, always, because x equals 0 is part of the domain. And so there's always going to be a y value when x is 0. Use this distance. Now, you can't see it very well, but this distance should be the same as that. So if 0, negative 5 is on the graph, then 1, negative 5 should be on the graph as well. See this distance? So I went 1/2. See, that's a half unit here. So that should be a half unit. See what I did? Let's see if I can go a little bit further up. I can't go that much. I can't zoom in that much further. But look, what I'm saying is this. The distance, see, this is 1/2, right? So 1/2 from the axis of symmetry, 1/2 from the y-axis, that's 0. 1/2. And so this has to be 1/2 as well, which is 1, negative 5. All right, so I have 2 points, and the only other thing I need is to find those x-intercepts. That's the only other thing I got to do. All right, so let's go ahead and do that. All right, so right here. Let me go ahead and zoom back out. All right, so let's find the x-intercepts. Now that's the one that's going to probably be the most work here. All right, so to find the x-intercept, remember you're going to let y equals 0. So remember, g of x means the same thing as y. So you're going to set this equal to 0. So 2x squared minus 2x minus 5 equals 0. Now what you're going to do is you're solving this quadratic equation. You're solving this quadratic equation. So remember, a is 2, b is negative 2, and c is negative 5. Again, be careful. All of this must be written correctly from here. But again, if you mess up here, you'll be able to tell because it won't look symmetrical anymore. When you kind of draw this parabola, it better look like a parabola. If it doesn't, then something's wrong probably here, because that's where the most work will be for this. All right, so let's talk about I'm going to go ahead and use the quadratic formula. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So my x-intercepts then will equal the opposite of b. Well, if b is negative 2, the opposite of that's a positive 2, plus or minus the square root of b, in parentheses, negative 2 squared, minus 4 times a is 2, times c, which is negative 5, all divided by 2 times 2. All right, and so you remember, now you kind of appreciate why you had to solve quadratic equations earlier, because it's needed here. So we have 2 plus or minus the square root of negative 2 squared is 4. All right, now a negative 4 times 2 times a negative 5. So negative 4 times 2 is a negative 8. A negative 8 times 5, negative 5, is a positive 40. All divided by 2 times 2, which is 4. So I get 2 plus or minus the square root of 44 over 4, divided by 4. All right, now remember, when you actually, in the previous lesson a while back, when you actually solved a quadratic equation, you were asked to simplify this radical. Don't do that here, because all you're doing is want to use this information to plot your x-intercepts. So just go ahead and use your calculator at this point. But remember, there are 2 x-intercepts. So you have 2 plus the square root of 44 divided by 4, and then 2 minus the square root of 44 divided by 4. All right, so let's kind of remind ourselves how to use a calculator with this. All right, so listen carefully. We're going to do the numerator first. Numerator first. So you're going to say 2 plus the square root of 44, close the parentheses, press equal. Don't divide by 4, okay, because then you're only dividing this by 4 when this whole thing needs to be divided by 4. Just press equal. That's your numerator. Now divide by 4. So I'm dividing the numerator by 4, and one of my x-intercepts is approximately equal to the nearest tenth, 2.2. So the nearest tenth, 2.2. So this is 5 or bigger. Remember, you got to add 1 to that. Okay, the next one. 2 minus the square root of 44, close the parentheses, press equal. That's your numerator. That is just your numerator now, but you got to divide by 4. So divide by 4, and the other x-intercept is approximately equal to negative 1.2. Okay? All right, now I want to show you something. See, if you add these two together, 2.2 plus a negative 1.2, you get 1, right? And then if you divide by 2, you get 1/2, which happens to be your axis of symmetry. And it kind of makes sense because, watch, when I plot those x-intercepts, and let me go ahead and zoom in, when I plot those x-intercepts, so one's about 2.2, 2 and 2/10, so that's about here, right here, just kind of estimate. And the other one is negative 1.2, which is about here. All right, so remember, if this were a segment, remember you found the midpoint of a segment before? If this was a segment, you would add these two together, divide by 2, and that gave you the midpoint. All right, so if these two when add together did not give you the axis, and divide by 2 did not give you the axis of symmetry, then something's wrong. So that's why you can very easily determine whether this is correct based on your graph. And then now notice, always keep in mind the idea of symmetry. So just make sure that this distance looks approximately the same as that distance. And then you just draw your graph and you're done. There's your parabola. Do the best you can with drawing a parabola. Make it look like a parabola. No segments. Make it look like a parabola. All right? And so there's your graph. All right, just make sure we answered everything. So we found the vertex. The domain's always going to be all real numbers since this is a quadratic function. It's a polynomial function. We found the range. The range kind of makes sense. You're going from the smallest y value, which is negative 5.5, all the way to infinity. So that kind of makes sense. The y-intercept is 0, negative 5, which is right here. And we have 5 points. 1, 2, 3, 4, 5. Okay? All right, so that's number 3. And that function was g of x is equal to 2x squared minus 2x minus 5. All right, now let's look at the next one, this one. So let's do that one. Okay, so let's find the vertex. I'm going to go ahead and do this in another sheet of paper. So this is going to be number 4. So number 4, my function is f of x equal negative 6x squared minus 4x minus 5. All right, so we need to find the vertex. When graphing, you're always going to find the vertex. So the vertex is hk, where h is negative b divided by 2a. All right, so remember, since this is in standard form, you have to use the vertex formula to find the vertex. All right, so let's determine what a, b, and c are. So a is negative 6, b is negative 4, and c is negative 5. Make sure all of this is correct. If something's wrong, the parabola will not look symmetrical. So you'll be able to kind of go back through and see, well, where did I make a mistake? Because it doesn't look like a parabola and it's not symmetrical about the axis of symmetry. Okay, so if b is negative 4, then the opposite of negative 4 is a positive 4, divided by 2 times a, which is negative 6. So I get 4 divided by negative 12, which reduce. I would go ahead and reduce this, which reduces a negative 1/3. All right, so leave it like that. Leave it as negative 1/3. I have a fraction again, no big deal. We can handle fractions. All right, now I got to find the y-coordinate of my vertex. So far, I know that my x-coordinate is negative 1/3 of my vertex. All right, to find the y-coordinate, remember that's going to be k, which is f of, in this case, f of negative 1/3. So basically, where we see the variable x, you're going to substitute what h is. Well, h in this case is negative 1/3. So I get negative 6 times negative 1/3 squared minus 4 times negative 1/3 minus 5. All right, let's use a calculator. Use your calculator. All right, so here's what we have. We have negative 6, so negative 6 times negative 1 divided by 3, close the parentheses. I must square that. So I'm going to square. Minus 4 times negative 1 divided by 3. Make sure you say negative now, otherwise you're going to get a different number. And then minus 5. And when I do that, I get this. Okay? Now remember, 0.33333 is 1/3. So that is negative 4 and 1/3. That's what that is, negative 4 and 1/3. Okay? All right, so I found my vertex. So my vertex is negative 1/3, negative 4 1/3. So we'll go ahead and write that here. So that's your vertex. So your vertex, I'm going to go ahead and zoom back out. All right, so my vertex is negative 1/3, negative 4 1/3. All right, now the domain. Remember the domain, since this is quadratic, the domain's all real numbers. Negative infinity to infinity, parentheses. Now let's talk about the range. All right, so first of all, let's kind of think about where the vertex is located. So the vertex is negative 1/3, negative 4 1/3. So that's in the third quadrant. All right, now the parabola opens down since a is negative, right? Parabola opens down since a is negative. So I know it's going to do this. So my question to you is this: are there going to be any x-intercepts? No, there are no x-intercepts. There are no x-intercepts. So for this little part here, you're going to say no x-intercepts. But again, you want to graph this using 5 points. So we're going to kind of review how to do that. Now let's talk about the y-intercept. You're always going to have a y-intercept. Remember, the y-intercept, you're going to let x equal 0. But remember, if x is 0, then that term becomes 0. That term becomes 0 because 0 squared 0. 0 times negative 6 is 0. Negative 4 times 0 is 0. And so your y-intercept is negative 5. So that's 0, negative 5. All right. So that's going to go here. Now, we forgot about the range, but let's talk about the range real quick before we go on. So remember, your parabola is up and down, right? So to find the range, remember the range is a set of y coordinates. So since the parabola is up and down, you're going from negative infinity, and then here's your maximum point. That y value, since we're finding domain, your y value, not x, your y value is whatever that y coordinate was here. So let's see, that was negative 1/3, negative 4 1/3. That's negative 4 1/3. So your largest y value is negative 4 1/3. Okay? So you're going from negative infinity, comma, negative 4 1/3 with a bracket. So that's your range. Okay, now let's graph what we have. All right, so this is going to be number 4. I think we can go ahead and use a smaller grid. So this is number 4. And number 4 was f of x equal negative 6x squared minus 4x minus 5. All right, so my vertex is negative 1/3, negative 4 1/3. So let me go ahead and zoom in. Now, you're going to have to estimate where that is, but that's okay. We can handle that. So negative 1/3 is on this side of the y-axis. All right, so it's on this side. And then negative 4 1/3, so negative 1, negative 2, negative 3, negative 4. So that's about, let's say, here. All right, so just estimate where that is. So that's about here. Okay, now your y-intercept, remember we said was negative 5, or is negative 5, so that's here. Next thing you want to do is draw the axis of symmetry to help you to graph the parabola. So it goes to the vertex. You can't see very well, but it goes to the vertex. It's kind of like this. Make sure it goes to the vertex. Make sure it's dotted line. Okay? All right, so that's what we have. Now use the idea of symmetry. So we found the y-intercept. So once you find the y-intercept, you can find another point. So you see that distance right here? So go that same distance here. So that's about here. So that's going to be negative 2/3. So this is 1/3. That distance is 1/3, which it is, because remember this is negative 1/3. So that distance 1/3, go 1/3 to this side. All right, just make sure that distance is the same. You can barely see it, but do the best you can. Okay, now we got to find one more point. Remember, we don't have any x-intercepts, so we got to find one more point. So what I would do then is this. I would go here and then just quickly use a t-table to find that one more point. Okay, I need one more point. Once I plot that point, I can use the idea of symmetry. Okay? All right, now the way I would do this is I would probably let x be 1. Let's go ahead and let x be 1, see what happens. So if x is 1, wherever we see the variable x, I'm going to go ahead and zoom out. Wherever I see the variable x, I'm going to substitute 1. So I get negative 6 times 1 squared minus 4 times 1 minus 5. So 1 squared is 1. 1 times negative 6 is negative 6. And then that's negative 4, and then minus 5. So I get negative 10 minus 5, which is a negative 15. So obviously I should have used a larger one. Okay, so let me go ahead and do that. Let me see, it only went down to 10. So let's use a large one because I wanted to use an integer instead of a fraction. Let's go and use a large one. So I'm going to do this one real quick. All right, so my vertex is negative 1/3, negative 4 1/3, so that's about here. And we found the y-intercept to be negative 5. So we drew our axis of symmetry. We drew the axis of symmetry, kind of like this. And then we use the idea of symmetry now. So this distance here should be about the same as on this side, so it's about here. And then we found another point of the graph. So another point of the graph would be 1, negative 15. All right, so when I do that, I get this now. Look, 1, negative 15 is here. Let's continue drawing the axis of symmetry a little bit further down to help us. like this. All right, now think. This distance right here should be the same as that distance, okay? So when I reflect this, I should get, let's see, this is 1/3. So do the best you can. So I should get something about here. That distance should be the same as that distance. All right, just do the best you can. It's no big deal. All right, and I guess something looks like this. Okay. Now the one in your test or worksheet should be a little bit easier to deal with. I had a bunch of fractions here, but it's okay. But that's what it looks like. All right. Just make sure that when you use the idea of symmetry, this distance is the same as that. Now be careful. Don't think that this is going to go here, because it's not. It's not on that where those two grids intersect, because remember, this is 1/3 right here, and this is 2/3. So you see, you got to be careful. So that's 1/3. So 1 plus 1/3 is 1 1/3, right? If you go here, that's 1 2/3. So you got to be careful. So it's 1/3 over here. All right. So do the best you can with doing this. All right. So there's your graph, and so so that should give you enough to do those two worksheets that worksheet that's dealing with graphing a quadratic function that's in standard form.